Okay, we're going to go over the first page, at least the most missed questions on the 9.1 quiz. First question says to compute the first three partial sums and the limit of the partial sums. And then we're doing that to determine whether the series converges or diverges. So let's find the first three partial sums first. So S sub 1 is the sum of the first one terms, which of course sounds a little weird. It's just 1/5. S sub 2, the second partial sum, is 1/5 plus 1/2, which of course, if you get the common denominator, is just going to be 7/10. And then S3 is going to be that 7/10 plus the next term, the third terms, which is the sum of the first three terms. So it's going to be the 5/4. So third partial sum is the sum of the first three terms. And if you get your common denominator there of 20, you get 39 over 20. So we've done the first part here. We've found the first three partial sums. Now we need to compute the limit of the partial sums. So the limit as n goes to infinity of big S of n. Well, big S of n equals a list of partial sums. So it's 1/5, comma, 7/10, comma, 39/20, comma. And this is getting bigger with each term. And so the limit of the sequence of partial sums is, of course, infinity. And therefore, our series diverges. So you could also notice that this is a geometric series, that you're just multiplying by 5/2 every time, so the ratio is greater than 1. And of course, that would prove divergence, but for this, it was required that you find the partial sums and prove the convergence or divergence by the limit of partial sums. This was worth 3 points. And so if you had the correct conclusion for a correct reason, even if it had nothing to do with these, you would have gotten 1 out of 3, 1 point, and then conclusion correct is another point. Second question now. We're on the second question. And it says just prove whether the series converges or diverges. So we need a good reason, a solid reason to show that. First thing I notice, of course, is that it's sine to the n. So we can rethink of this as just, and I'm not going to put all the bounds on here just for the moment, but sine of pi over 6 plus pi n raised to the n power. So r is the sine of pi over 6 plus pi n. Oops. So the question is, what is pi over 6 plus pi n, right? What does that do? Pi over 6, sine of pi over 6 plus pi n. So I go ahead and I calculate, hey, the sine of pi over 6 is going to be 1/2. You either memorize your unit circle, or I always just look at the triangles and think of that. And then you add pi to that, and you get that the sine of 7 pi over 6 is just going to be negative 1/2. And then, of course, you're going to have the sine of 13 pi over 6, which is just going to be the same as sine of pi over 6. So then it's 1/2, the negative 1/2. And so you could pretty quickly conclude that r equals negative 1/2. Once we have that r equals negative 1/2, now we've got this thing solved. Okay? We've got this thing solved. So at that point, we've got r equals negative 1/2. So now we know it's a geometric series. We know it's a geometric series, and we have the absolute value of r equal to 1/2, which is less than 1. Therefore, it converges. Okay, so we know the series converges now, and it converges, and we're asked then to find the sum. So the sum is going to be s equals a over 1 minus r. First term, a, plug in 0 to this. Sine of whatever to the 0 is going to be, of course, 1. So we get 1 over 1 plus 1/2, because r is negative 1/2. So 1 minus r is going to be 1 plus 1/2. So we then get s equals 1 over 3/2. So s equals 2/3. So the sum is 2/3. Now on to the third question. For the third question, again, we're asked to prove whether the series converges or diverges, and we have a similar style problem. We have an r, and of course our r in this case is going to be the cosine of 2n pi. 2n pi. And so we have to ask ourselves, what is 2n pi? Well, if you think about it, the cosine, when you plug in 0, the first thing you get, when you plug in 0, first thing you get for that is the cosine of 2 times 0 pi, which of course is the cosine of 0, which is 1. And then when you put 1 in, you get the cosine of 2 pi, which is of course 1. And so then you get the cosine of 4 pi, which is of course 1. And so this series is just, right, if we want to look at what is this series, right? We want to look at what is this series, okay? This series is just going to be 1 plus 1 plus 1. And so really, this is just a geometric series with the absolute value of r equal to 1, which is not less than 1, therefore it diverges. So that's one way to do it. An even faster way to do it, or another way to do it, is to simply say, well, what is the limit? Right. So there's a different way. So I'm going to go ahead and go to a different color, actually, I guess. So what is the limit as n approaches infinity of the cosine of 2n pi to the n? That's, of course, just 1 to the n, applying that same limit. And the cosine of 1 to the n, when you take the limit as n goes to infinity, is going to be 1, which is not equal to 0. Which does not equal 0. Therefore, it diverges. So, two different ways to do it. You show that the nth term has a limit as you go to infinity of 1, which is not equal to 0. Therefore, it diverges. Or you can identify that it's a geometric series with r equal to 1, absolute value of r equal to 1, which is not less than 1, therefore it diverges. And then the last question that I'm going to go over real quick here is prove whether this series converges or diverges. And this one, I think, is the easiest or fastest, most straightforward one. Now, first I want to point out that this one is definitely not geometric. There's not even an exponent in the problem, so clearly it's not geometric. But just take a look. The top and the bottom, when you go to infinity, are essentially the same. And that's the whole point of this one. So the limit as n goes to infinity of n plus 2 over n plus 5 is 1. N behavior, which does not equal 0. Therefore, this series diverges. So you can see that this problem, as long as you're confident with the fact that any convergent series must have the terms go to 0, otherwise it diverges, as long as you're confident with that, this problem should take you 15 to 20 seconds. You don't even need to write the not geometric. It's just this. It's just realizing, oh, those don't go to 0. And then you need to officially write it correctly. The limit as n goes to infinity of n plus 2 over n plus 5 equals 1, which is not equal 0.